Hello everyone, my name is Vikas and I welcome you all in this post-contest discussion of CodeChef Starters 252 DU4 and we will solve 6 questions in this video. So first of all, let me check if I'm audible and we are going to start this discussion in less than 1 minute. Welcome you all in this post-contest discussion. Okay, so let's start our discussion with the first question of the contest. Also, let me know in the live chat how many questions you were able to solve in this contest and also how was the contest. Okay, so let's see the first question, which was really easy. In this, Chef recently participated in a IUI competition and scored N points out of 600. And the goal cutoff is also released. So, which is G points, right? So, everyone who have at least G points will get a gold medal. And we have to find if he will get a gold or not. So we have to print yes if he wins a gold medal and no in the other case. So see, this thing was easy. We just have to see that the chef's point, if it is at least G points, then we have to print yes. He will get a gold medal, else we have to print no. So that's it. So let's say there are two variables given to us. One variable is, so this is our question A. So we have two variables given. One is, let's say, the points of the chef, and G, which is the cutoff, or let's say it is cutoff. Instead of G, let's call this variable cutoff. So see, if the point we have is at least or is same or greater than equal to the cutoff, then we have to print yes. If this is the case, then we have to print yes. Else we have to print no. So yeah, that was it in this question, and the code is also only this thing. We just so we take the input of two variables. One is the point the chef has and the cutoff for to get the gold medal. And if point is greater than or equal to cutoff, we print yes, else no. Yeah, that's it. And this, sorry, okay, 4 question you did. Okay, that's good. So okay, the first two are very trivial. Let's go to the second question of our discussion, which is the mirror swaps. So in this question, we are given an array of size 2n. And yeah, we have to be slightly careful about this type of things, right? The integer is n and the size of the vector will be 2n. And we can perform a following operation as many times as we want. We can swap ai with a of 2n plus 1 minus I. Okay, what does this mean? This looks slightly weird. Okay, so let's first of all analyze this thing. What does we mean by swapping by the mirror point? So this is question B. Okay, let's assume that my array is like this. Array is A1, A2, A3, A4, A5, and A6. Yeah, the size is going to be always even, that is given to us, because the size is 2n. Now, which elements we can swap, right? We can swap AI with A of, sorry, this is AI, A of 2n plus 1 minus I, right? A of 2n or 2n plus 1 minus I. So let's say, what if I have A1, then the first element A1 can be swept. So here I is equal to 1, right? So can be swept by 2n. So like in this case, n is going to be 3, right? So 6 plus 1 minus 1, that will be A6. So A1 can be swapped with A6. Then yeah, same thing. You will get A2 can be swept by A5 and A3 can be swept with A4. So yeah, you can see that this is something like this. So yeah, by the mirror point, they mean that yeah, we can swap like this. If this is the middle point, so you can see that the mirror point of A1 is somewhere here, right? A6. The mirror point of A2 is A5. A3 with A4. Okay, and let's see what the question is asking. We can swap like any of this with its mirror point, and we have to find what is the maximum value of A1 plus A2 plus still A of n only, right? So this is still A of n only. So sum of the first half of the array, we have to find its maximum value. So okay, this was again not very tough. So see, we have to what we have to do? We have to maximize this sum of this first half, right? Okay. So let me ask you a question. Let's say this value is 5. Let's say this value, it is 10. So will you do swap or not? Right. So you can say that at the first position, there are two candidates, right? Either this 5 will stay at this point or the mirror point. This is also a candidate to be a first place, right? This 10 can also be come at first place. Which one will come at the first place? The maximum one, right? Because see, we want to maximize the sum of this. So if we want the maximum sum, we want to maximize all of these values also, right? So yeah, I mean, this thing was easy. See, this is the first element. There are two candidates that can come at the first element. One is A of 1 and A of 6, right? Or you can say A of I and A of 2n plus 1 minus I. Whichever value is maximum, you will put it here, right? So this will contribute like maximum of this much. Okay, so see what I want to say is that let's say my n is equal to 4 and my array is like this. Let's say so there will be 2n means 8 elements in this array. Let's say elements are like this. Okay, so see, this is the first half, right? Then I come to the first place, right? And see, the value is 1. And the mirror point has value 7, right? So what I can do is I can swap this. And if I swap, then 7 will come here and 1 will come here. So you can see that this 7 will contribute in this answer, right? Sum of this thing. So it is a better choice. Like see, even if I just like swap them again, I'm going to get 1 again and 7 here again. So swapping 2 times doesn't help us. So okay, this thing is better for me, right? Because see, this was contributing just plus 1 in the answer, and this is contributing plus 7 in the answer. So therefore, this thing is better. So we can say that I will swap, and now at the first position, which person will come? 7 will come. So see what 7 will come at the first point, and it will contribute plus 7 in my answer. Let's say the same thing for this second element. So you can see this is the second element and its mirror point is going to be this one. So like both are the same, right? So even if you swap or not swap, this thing is going to be same at this point. So this is going to be contribute plus in the answer, right? So let's also like draw this. Okay, we have done this swap. ठीक है, हमने ये swap कर दिया था. So therefore 7 will come here. Uh, let's say what we can do for this element. This is 2, this is 4. So of course we will swap and put the 4 here. So let's do this. So 4 will come here, 2 will come here, and now this will contribute plus 4 in my answer, and for this 2, I will not swap, so this will contribute plus 6, right? So sum of this thing is 7 plus 3 plus 4 plus 6, and the answer is going to be plus 20 for me. Okay, So that's it. I mean, that's all you have to do in this code. So see, for the first n elements, you will see and find that which one will come to that point, right? Like you will find that which element will be at the first index, and that element is going to be maximum of a1 comma a8, right? Like either this one or this one, you can see this element, like which element will be there after you do the step. The element will be maximum of a2 or this a7 or this a7, right? This element will contribute maximum of a3 comma a6, and the fourth element will contribute maximum of like a4 comma a5, right? Like how can I say maximum of a4 comma a5? So see, this a4 is 6 and this a5 is 2. So what I will do is I will keep 6 at this point only, right? So maximum of this is 6. So I will keep 6 at the fourth index, and in the sum I will add 6 in my answer, right? Like, so I will do this plus max test. So that's all we have to do, and like iterate on first n things, like the first half of the array, just n elements, and add this thing into the answer. That's it. And what this is, so for the ith point or for the ith index, it is going to be maximum of ai and 2n minus, sorry, 2n plus 1 minus I. That's it. And also there is another thing, another note you should like consider with this is, if the elements are in one based indexing, right? If the elements are in one based indexing, then the mirror point of ai is going to be a of 2n plus uh, 1 minus I, right? So like you can see that for a1, the mirror point is, in this case, the mirror point is a8, which is this. Okay, so for the a1, the mirror point is 8 plus 1 minus 1, that is a of 8, right? That is a of 8. That is correct. But if we solve this in zero based indexing, then you have to like reconsider this formula. So see, let's write, okay, let's derive this formula. I mean, let's see. So let's say there are 6 elements, n is equal to 3. So there will be 5 elements, right? And the a1, a0 will have mirror point a of 5. So how we can like get this? So see, when I is equal to 0, the mirror point is a of 5. So this should be something like 2 raised to n minus I plus or minus something, right? Like this addition will differ. So let's, I mean, try to make this. See, 2n is 5, like 2n is 6. Okay. So like in the contest, I did something like this. This is 2n. For sure, I have to do the minus I. So this minus I is 0, right? So this is our I. So you can see this is still 6. So I have to do minus 1 here, extra. So by that way, I got the formula. I mean, see, that's it. So now my formula is that mirror point will be, for the AI, mirror point will be a of 2 into n minus I minus 1. Let's check this. So for the a0, the mirror point is 2n is 6 minus 0 minus 1, a of 5. That's correct. For a1, the mirror point will be 2n is 6 minus I is equal to 1 minus 1. This will be a of 5. This is also correct. And yeah, for the a2, a3, this will correct. So this is the formula. So that's it in this question. If you have like any doubt, okay. Thank you for showing your love. So let's read the code and you will understand this better. So see, what we did is that first of all, I take the input. Remember, the array is of 2n size, so I have to make the array of 2n size and take the input of the array. And now I iterate on this first half of the element and see the contribution of that point, like the ith point, is going to be like maximum of this or this, right? Whichever is maximum, I will place at this ith index. And in the sum, this will contribute this much. So yeah, that's it. So therefore, answer plus is equal to either current element or the mirror element. So I do this n times and I print the answer. Yeah, that's it in this question. In case you have any doubts, you can share it in the live chat. Okay, let's move to the third question. Okay, so third question is odd even. So array B is called good if the parity of the elements keep alternating, right? So it means that first element is odd, second one is even, then odd and even and so on. Then we are given an array A containing n integers and we can do the following. What we can do is we can choose a subset of A and then rearrange them to any any way I like. So okay, and I have to find the maximum size of the subset I can choose that can be rearranged and then it will be a good array. Okay, everything correct. Okay. Sure. In this question, n is still 100 and t is still 100. So yeah, there is no big issue of time complexity. We can solve this in O of n, n square or n cube. Okay, we cannot do in n cube because t into n will be 1e4. Okay, we can do this in n or n square. So let's try to analyze these questions. So this is question C. Okay, so first of all, let's assume that we have some array and array is like this. So in this question, the first thing or first observation you should see is that we don't care about what is the number, right? We don't care about what is the value of the number. We only care about if the number is odd or the number is even. So can I say that I don't care about this number? I can just make a new array, or like I can just group them into parts, like if it is even or it is odd, right? So yeah, if I can change this, so this is odd, this is even, and this is even, right? So I can just change it in some array like looking like this, and then it will be better for me to solve, or better for us. Okay, so we have some array like this. What I can do is I can choose a subset like this, or no, let's say I choose a subset like this. So yeah, my subset is this and this and this. So there are two E and there is one odd element, and I can rearrange that, right? So see, there is one odd and two even elements. I can rearrange them like this: even, odd, and even. And now we can see that this is even, odd, even, alternating, right? Okay. Also, let's say we can choose some subarray like this. So now there are four elements, two odd element and two even elements. I can rearrange like even, odd, right? And they are now alternating. Okay, so first of all, we have to find some condition for this. Like let's say if I have x odd elements and let's say y even elements in the subset, right? I have choose this much elements from the subset, and I ask you that, hey, let's say I given you this much odd and this much even elements. Can I rearrange them and make them alternating? That's the question. So let's try to find some property of this. Okay, we have some X odd and even. So, okay, let's try. Let's say I have four even elements. This is fixed. So this is how like I think in the question. So let's say I have four even elements. Now see, this thing should be alternating, right? So one odd must be here. One odd must be here and one odd element must be here. Okay, so if I have four even and three odd, then that's fine. It can be alternating. Let's say I have only two odds. Then it can never be alternating, right? Because see, there are two even adjacent elements. So this is not alternating. Okay, so this is for three. Let's say if I had four even elements, then also the thing is clear. Like I can make one odd here, and now you can see that this is still alternating. Or I had five odds, then you can say that in this case, this is alternating, right? I have four even, five odds, and this is still alternating. Now let's say I have six odd. If I have six odd elements, where I can put my odd element? There is no place where I can put my sixth odd elements such that it will be alternating. So that's it. So we got some condition like this. Okay, and more like formally, if I say that, let's say I say that the minimum number of, uh, okay, just give me a minute. Okay, yeah, so see, let's say if I tell you that my odd elements, I have four odd elements and I have seven even elements, then what we can do? So see, we can put four elements, and now from the seven elements, I can take only like this is the total. Okay, so I can take only five of them, and I will okay, sorry, I can put five even elements like this, right? So like see, all the minimum, like this is minimum, right? So all the minimum element I can put them, and then for the even elements, like this is the maximum, I have to skip some of them, right? So I cannot use all of the seven. So how much maximum I can use? So see, if the odd elements I have is four, then I can use maximum five elements. So this is some type of like capping there, right? This is saying that this is saying to even that hey, however element you have, you can use maximum of five elements only. That's it. So yeah, something like this. So okay, let's see another case. This is odd elements and this is number of even elements. So let's say number of odd elements I have is 10 and number of even elements I have is let's say 6. So this is 6, right? So first of all, we can for sure say that in my answer, I can put 6 odd elements. I can put 6 even elements, sorry. Right. All these elements, so this is the minimum. So there is no like tension of this thing. I can put all of them. And now for the odd. See, there are only 6 even. So this even will say that, hey bro, how many elements you have? You can just use at most 7 of them, right? Which is even plus 1, right? You can just use at most 7 of them. And yeah, this odd will say okay, and he will just use 7 of them, right? So 7 elements will come here, something like this, and this is my alternating pair. So that's it. Okay, there is also another case, right? Let's say this is also 6. So see, this even will tell the odd that how many elements you have. You can just use 7 of them, at most 7 elements. This odd will say, okay, like this 7 is the range and I have only 6. So I can use my 6 odd elements. And yeah, the 6 odd elements will be something like this. So Yeah, I mean, you can just say that how the capping is working, right? So what I can say is that whatever is minimum of this even and odd, I can put them, right? See, in this case, the let's say even is smaller, so I can put the all the six even elements, and for the maximum element, okay. See, for the maximum element, let's say whatever is this, there is a cap. What is the cap? That like I can only use this much plus one elements. Okay. Okay. Let me be more clear. Okay. So see, let's say this was 10. So this I have the minimum of odd and even will be 6, and the maximum and odd and even of odd and even will be 10. So I can use the 6 elements, this minimum of this, plus in this maximum element, there is a capping. What is the capping, right? What is the maximum I can use? The maximum I can use is 7, which is min plus 1, right? So there is a capping like this, min of even plus or plus 1, plus 1. See, whichever is minimum, I will take that. So, okay, this was the formula. I mean, like there are several ways you can make there are several other formulas also. One nice formula is the one that this person gave me. Too many submissions so fast, making me demotivated. I did only the max and max question only, still nearly 1000 rank. Okay, I mean, see, that's fine. Like, don't see the submission in these days. There are so many like people who are cheating. So yeah, don't get demotivated by that. I mean, if you want to actually like practice and you have to see that where you stand, you should give the old virtual contest, right? Because in that time there was like less people who were cheating, so you will get the idea that where you stand. But yeah, in the current days, there are so many people cheating. So this is also like another formula. See, I mean, yeah, the idea was something like this, that there are 6 and 10. So what this will tell me that this is 10. This capping is 6. Whatever is smaller, that will be the answer, right? Okay, and there is another good thing. So see, one case is clear, right? Let's say the odd elements and the even elements. If let's say both are equal, then the answer will be nothing but 5 plus 5, right? That's it. But let's say what if they both are not equal? Something like this. So in that case, I will use all the min elements. I will use all the minimum elements or anyone. And in this, like here, I will use like for this, I will use min of odd plus even element plus one only. See, like there are 10 elements. There are 10 elements of maximum, but I can only use 7 plus 1. That's it. So from this, I will use only 7 plus 1, which is 8. So I will use 7 of even and 8 from odd. So this total will be 7 plus 8. So yeah, you can just make it into two cases, right? If odd is equal to even, you will print uh like both are same. So you can print odd plus even. So this O is telling me the number of odd elements, and this is telling me the number of even elements. Else you will just print the minimum of odd and even. So this is the contribution from minimum thing, plus you will minimum of odd and even plus 1. So this is also another formula, like you can try. I joined 23 minutes late and solved CDE in 21 minutes, but I didn't get the F. Okay, yeah, the F was real interesting question. I mean, this was amazing. Max and Max, I tried with forced at DP. I got TLE. I mean, of course you will get TLE in this Max and Max question because This is still 100 and t is still 100. So the summation of n can be till 1e4. So you cannot use the four state DP if every DP is still like if every state is from 0 to 1e4. Minimum of n and minimum of 2 into min over c plus 1. Okay, this is also what to say. Okay, this is also a weird formula. I mean, okay, yeah, you got it, Celis. That's good. So let's move to the fourth question of our discussion, and this can be done by the many methods. So let's read this question. So the name of the question is skip one, and in this question we have k coins, and there are n items, and the item cost you ai coins to buy. So the price of ith item is ai, and we have a special one-time discount coupon. This is one time, and which can be used to make one item of your choice free to buy. And but we have a constraint to buy the item in order 1 to n. So yeah, this is like I have to buy all items in one order, right? First of all, I will buy the first item, then and only then I can buy the second. After that, I will buy the third item and so on. Like I cannot buy just the fifth item directly. First, I have to choose first I have to buy the first four items. Yes, and I have to find the maximum number of items we can buy under this constraint. So like see, if this special coupon was not there, then the idea will be easy, right? We will just buy the first item if we can buy. Then we can, if I will see that, can I buy the second item? If yes, then I will buy them. And yeah, I will keep doing this. That's it. But yeah, there is a special one-time discount coupon, and where I will use it. This is also a big question. Okay, t is still 1e4, n is still 2e5, so we have to think something in O of n or O of n log n. Yeah, the values are till 1e4 and k is till 1e9. So the k is the money we have. Okay, this was an interesting question. Let's analyze this. So this is question D. Okay, so let's assume that the number of coins I have is 20, and the array, which is the price of each item, is let's call this price array, and this is like, let's say 3, 1, or 5, 15. Okay, not 15, let's say 10, 6, 20, and 2. Okay, this is our array. So the only question of this, like the main part is this question that from the free ticket, which item I will buy. So this is like the main part of the question, and there are so many like ways you can think, right? In the greedy way, you can just say that, see, I will always buy the item which has the maximum value, right? Okay, let's try this. See, in this case, let's say you bought this value, like this item, which is the maximum among all of them, and you buy this with the free coin, with the free ticket. Like you just, like you don't buy this, you just assume that, okay, I will buy this with the free ticket. So then you start from like buying from this. You see this element, the price is 3. So you buy this, and now my coin are 17. You come to this, you buy this, and now the coins I have is 16. Then we go to third element, we buy this, and the coin we have is 11. We go to this, now the coin I have is 1 only. Now I go to this, and now I will stop, right? Like because I cannot buy this, sorry, I cannot buy the fifth item from the number of coins I have. And what? So I will have to stop. And also the thinking that I will buy this with the my free coupon, that will not work because I cannot even come till this point, right? I cannot even come till this point. So this is the idea. So this greedy idea will fail. So we have to think some other idea, like what we can do. So there is also one. Okay. So there was a good observation in this. What I can say is that, okay, I say you that with the money I have and one free coupon, I can buy first four, or let's say first five items. I say you this. Okay. So then, can I for sure say that if I can buy the first five items with the money, I will always like I can always buy the first three, right? Or I can also buy the first four elements, right? I mean, see, with the 20 coins and the free card, I can buy this much. So I can definitely buy the first four only, right? So this also I can buy. First three elements also I can buy. First two elements also I can buy. And yeah, the one element only I can buy. Sorry. And then let's say I say you that I cannot buy this first six element with the money I have. So then I can for sure say that I cannot buy the first seven elements. Because see, even if I cannot buy the first six elements, how am I going to buy the first seven? So yeah, the this looks something like this. And you can be like, this is a easy observation that on this type of intervals, you can do binary search easily, right? Because see, what we have to find, we just have to find the rightmost item such that we can buy this whole range. That's it. And for that, we just have to do the binary search. Like we can do that by binary search. So this was the idea, and like with the binary search, this becomes easy, right? Because see, let's say my mid is this, or let's say my mid is this, okay, and my because see by the binary search, the question reduces. Like now the question becomes something like, can I buy this range from let's say one to some element? Let's say the element is mid. Right? The question is like this. So if my mid is at this point, the question I will ask is that can I buy this range, like this whole range? Can I buy this whole five elements? And if I have this type of thing that I have to buy all, right? I don't want what is the maximum I can buy. I just have to check yes or no. Can I buy all elements or I don't? Uh, okay, you are overcomplicating. We just have to do greedy thing. Yes, this is correct. I mean, yeah, this greedy method is correct, but we can also use the binary search. And the binary search is like more of educational thing. So this greedy may or may not like come to someone's mind, but the binary search thing is easy. We will like I will explain both of the methods. You can use prefix sum and prefix max observation. No need of binary search. Use free. Okay, that's correct. That's definitely correct. We will come to this type of this type of solution. Okay, and see in this case, the solution becomes easy because see, I have to buy all of them. So then I will for sure say that I will buy this item with coupon. That's it. And all of the other items with the money. And then if I can buy all, then yes. Else I cannot buy this. So that's it with the binary search. Okay. So also like let's try for this range. Like let's say if I want to find for this range 3, 1, 5, 10, 6, and 20. So see the idea is that if I have to buy all of them, like all of them will be bought, right? So I will buy the max one with the free coupon. This one with the free coupon. and all of the other one will be bought by the money. So the sum of this, which is 4, 9, 10, and 25. If the other thing I can buy with the money, so in this case, which is no. So then the answer is no. So yeah, this was the first approach, and let's go to the second greedy approach. So the greedy approach is just like what you think, like whatever, like it's the method we will use in real life. 3, 1, 5. Okay, let's say my array is like this: 3, 1, 5, 10, 6, 20, and 2. So okay, and the k is 20. Sorry, k is 20. So I will start from this. Can I buy this? Yes, I can buy this. I will buy this, and my money I have is 17. Can I buy the second one? Yes. So I will buy this, and the money I have is 16. Here I will buy this, and now money I have is 11. Here I will buy this, and the money I have is 1. And then I come to this point and see, I cannot buy this one. So now at this point, I will stop and I will say that, okay, I cannot buy this with the money. So now I will say that in this first 5, I must use some coupon, right? Because if I don't use any coupon, I will just stop at this point. So I have to use some coupon. One thing is I can use the coupon on this current element, but this may not be optimal, right? Because see, the previous element is 10. If I use the coupon on this thing, it will be more better for me. So the idea is that wherever I stop at this point, I will see that which element is the maximum among them. I can use coupon in one of the among it. And from I will choose the maximum one, and I will use the like free ticket on this thing. And now the idea is that see, initially now see k is my 1, but instead of paying 10 rupees, like 10 coins, this is free for me now, right? So this money will be added by 10. So the money I have will be 11 now, right? Initially it was 1, the money. So now if I buy this with the free coupon, so see, I paid, okay, I paid 10 rupees or 10 coins for this, but now this is free. So I get my 10 rupees back, something like this. And now again, I will just keep moving, right? So see, now I have 11 coins, and again, just the same procedure like before. Can I buy this? Yes, I can buy this. So I will buy this, and money I have is 5. And now I come to this. I cannot buy this, and I have used my free coupon. So yeah, I just stop at this point. So I know that the maximum thing I can buy with the money is this much. So yeah, that's just the logic, right? I will keep moving. If I stop at some point in this range, I will say that what is the maximum thing I can buy with my money? Sorry, with the free ticket, I buy that. I like recollect my coins. So like from 1, my coins will be 11. And then again, I start moving ahead and see. So yeah, that's it. You can also use prefix sum and prefix sum observation of this problem model. Yeah, that's correct. And also the thing is, whenever I go right, I keep the note of what is the maximum element I have got till now, right? I keep the variable, which is the maximum element I have got till now. So let's read the code. And also, okay, this is my code. So I take, this is the input, this is my max variable. Okay, so this will tell me that maximum uh, price of item, maximum item price till now. This will tell me that have I used my ticket or not? Ticket or not? So see, if the flag is 0, it means that I have not used my free ticket, and if it is 1, then it means that I have used. This is my total money, and this is the number of elements I have bought. Right? This is my just my answer, or you can say the number of elements I have bought till now. So I start moving. And yeah, first of all, I just recalculate the max thing with this maximum of ARR of I and MX, because now I can also buy this ARR of I with the free ticket. So that's it. Now see, if I have enough money, so this is the case of enough money. So I will do nothing. I will just buy this with the money, and now my money I have is money minus this. Now I cannot buy, like the another case is I cannot buy, and I still have a coupon. So in this case, uh, what we'll do is that whatever the maximum item was that I will buy this for free. So my money will be added by this MX, right? So see, let's say if my array was something like this, and now I'm at this point and I cannot buy this element and the flag is equal to 0. So my maximum will point to 10. Maximum will be 10, which means that this element. And I buy this with the free coupon. So now my money will be added by 10. That's it. And then I buy the current one. Okay, so like I buy the sixth element with the money. So I do money minus equal to ARR of I, and I do flag plus plus, which means that money is bought. And this is the case that else it means that I don't have money. So like not enough money and also no coupon. So in that case, I can't do anything. I will just break at that point. And yeah, I just keep doing C and T++. And in the end, I just print the answer that how many elements I have bought till now. So that's it in this question. Max A of yes, and if sum of A else. Okay, yeah, that's right. I mean, you can also break at that point exactly. But I mean, I have to like write this more professionally, or you can say. Okay, then let's move to the fifth question of our discussion, which is max, MEX, and max, which is MAX. So we are given array A containing n integers, and we have to find the number of subsequence B of A such that the MEX of the B minus MX of the B is less than equal to 1. Okay, this is interesting. And I have to find that number of, okay, I have to find the number of subsequence such that this condition is hold. That's it. And T and N is still 100 and 100. So we have to do something in, because yeah, the summation of N will be around 1e4. So we have to do something in O of N or O of N square. We cannot use N cube or N raised to power 4. Okay, so first of all, let's analyze this condition. Okay, so this is our question E. Let me zoom out this. Sorry. So the condition is that this MEX of some subsequence B minus the max of some subsequence B should be less than or is equal to 1. So from this, there can be three conditions, right? One condition is that MEX of B minus max of B is equal to -1, or this MEX of B minus the maximum of B is equal to 0. And the third condition is that this max of B minus maximum of B is equal to +1. So these are the three conditions only, right? Because if any of this condition holds, then this will hold. That's it. Now let's like try to find like what for what each condition the subsequence look like. So let's see about the first condition. The condition 1, which is MEX of B minus maximum of B is -1. Okay. Okay, Sujal is saying, I don't understand this, why this has less constraints, because if mn is less than 100, because we can do this in O of n only. Yeah, that's correct. I don't, like, I also still thought that in the contest. Like, I thought that this solution is O of n, but they require O of n square. Then I just thought that why, like, I just thought if my solution is wrong, but yeah, this can work in O of n. So, okay, this is the first condition. Okay, and now we have to find something like what is the condition on the subsequence, or how the subsequence can look like if it has this condition. Okay, so let's say for some subsequence, the maximum is what? Let's say the maximum is 5, and max is 5. Then in that array, the max, this should be equal to what? So in that array, the max should be 6, right? So let's, like, if the max is 5, then I can for sure say that 0, 1, 2, 3, and 4 will be in the array, and this 5 will not be in the array, right? I can for sure say that. Is this clear? Because then and only then the max will be 5. If any of this is not in the array, then the max will be this only. And if 5 is in the array, then the max, like the max can never be 5. And yeah, I want maximum is equal to 6. So 6 will also in the subsequence. Also, you can see that 7, 8, or anything else can never come. And so this is fixed, right? Okay, so this is the only subsequence which has max is equal to 5 and max is equal to 6. That's it. I cannot add any other element, or also I cannot remove any of this. That's it. So this is interesting, right? So there are not much subsequence. See, the subsequence can look like, let's say this is there is 0. Okay, so let's say there is only 1. So which means that max is 0 and max is equal to 1. The subsequence can look like this. The subsequence can look like this, or let's say, so see, like there will be some continuous number of elements, then there will be one break, and then there will be one another element. That's it. uh, Sorry, this will be 5. So these are also, you can see that uh, n is still 100, right? So there can be only 100 subsequence like this. You go, right? So this is one observation. I mean, see, if I find that how many subsequence in the array I have that are of type this, I mean, which is 0 and 2, then it's okay. Okay, also, like, I forgot to tell you one more thing. I mean, there can be many occurrence of this thing. It doesn't matter. I mean, see, instead of the subsequence, sorry, the subsequence looking like this, it can look like this. Sorry. Right. I mean, yeah, any element can have more than one frequency, because it doesn't affect in the max or this maximum. It doesn't affect. Okay, that's fine. But the thing is sure that there should be at least 1 0, right? At least 1 0, one occurrence of 0. There should be at least one occurrence of 1, one occurrence of 2, one occurrence of 3, 4, and 6. And there should be no occurrence of any other element. Yeah, that's it. Okay, that's fine. Let's go to the second type of case, which is MEX of, sorry, that is that MEX of the subsequence minus the maximum of the subsequence should be equal to 0. So which means that, yeah, the maximum of MEX of B should be equal to the maximum of B. Okay. So let's say my MEX is equal to 4. So in that case, for sure, I can say that 0, 1, 2, and 3 will be in the array, like will come in the sequence at least once, and the 4 will never come. Like 4 will never come, or you can say 4 will be never present. And okay, so if the mx is equal to 4, then the maximum should be 4. This means that the 4 should be present in the subsequence, but we already have this condition that the 4 can never be present. So therefore, we can say that this type of condition, like this type of condition can never happen. Or you can say that there are no valid subsequence, right? Because the idea is if mx is equal to 4, then 4 can never be in the array, but maximum is equal to 4, which means that 4 should be in the array. And these both are contradicting. That's it. Let's go to the third condition, which is mx of b minus maximum of b should be equal to plus 1. So which means that max of b is equal to mx of b plus 1, right? So assume that we assume that, let's say, take one example and assume that max of b is equal to 4. So in that case, 0, 1, 2, and 3 will always be present and 4 will never be present. And what we want about max, okay, I think I wrote it wrong. Sorry, this should be minus 1, right? Yeah. Okay, so my max will be 3. Okay, and you can see that the maximum is already 3 of this subsequence, right? So I cannot add any other element, right? Because if I add any other element, then the maximum will grow. So, okay, that's it. So if I want this condition to hold, I can definitely say that the subsequence will be some like continuous segment, right? Let's say 0 or 0, 1 or 0, 1, 2 or 0, 1, 2, 3. Everything has like in the both this condition is satisfying, right? Or 0, 1, 2, 3, 4 and like so on. And again, you can see that n is still 100. So there will be at most 100 subsequence like this only, right? Like the maximum subsequence will end at 100. That's it. So like in particular, there are 101 subsequence like this. No, only 100. Sorry, there are only 100 subsequence. So yeah. So there are going to be 100 subsequence, or you can say n subsequence. Now the question is about finding that. Okay, let's say I fix some subsequence. Okay, let's say I fix this subsequence now, and I ask you that I say that, bro, you have an array. I give you array of length n, and each element is less than equal to n. And then I ask you that in this array, how many subsequence there are that have at least one occurrence of 0, at least one occurrence of 1, at least one occurrence of 2, and at least one occurrence of 3. And no other element should be present, right? That's it. Okay, I mean, okay, so yeah, because the idea is that, see, uh, my subsequence can be like this. So I don't care about how many occurrence there are of 1, 2, 3, or 0. I just care that there should be at least one, because see, if there is let's say no occurrence of something, then the max will be 0, right? So I don't want that. There should be at least one occurrence of everything, and none other element should be present. That's it. Let's say I ask you this question. Okay, forgot everything. This is the part 2 of the question. How can we solve this? Okay, and in this, like, the idea is simple. Let's say this is my array. and I ask you that how many subsequence are there? How many subsequence are there that contain only one? Okay, how can you solve this? So, I mean, if you know some like combinatorics, then you will like easily able to solve this. The idea is that see, there are four occurrence of one, right? And I can use any of this. So let's say this is index 1, 3, 4, 6, and this is a 1 on the index 7. So there are many ways, right? I can use the one index of the index 1. I can use one in uh, one in element on the index 1 and one on the index 2, right? So like subsequence will be this. Also the subsequence can be like this. So I choose this, this, and this. Okay. So the idea is you can also like write all the subsequence that are valid and you will get one observation from this. But this is like some fundamental part. The answer is nothing but, so there are four ones, right? Four occurrence of one. So the answer is C. Okay, more better, I can say that see, there are four elements. I just want how many subsequence there are made from these four elements only. If I ask you that, the answer is just 2 raised to 4. But in this, I have also counted one empty subsequence. Okay, sorry. Right, this empty subsequence will count it, but I want at least one occurrence of one, right? So I will do 2 raised to power 4 minus 1. That's it. And yeah, and like the idea behind that is simple. See, these are my four ones. So what I can see on them, I will come here. There are two options, right? There are two options. Either I take or not take. So there are two options for this. Again, for this, I can take this in my subsequence or I can not take this in my subsequence. There are two options for this. Then there are two options for this and there are two options for this. So yeah, the answer will be just 2 into 2 into 2 into 2, which is 16. But there will be one case, right? The one case is, let's say I don't take this, I don't take this, I don't take this, and I don't take this. So in that, the subsequence will be empty and I don't want that. So I will do minus 1. Okay, that's it. So let's try a different type of query. Let's say my array is like this. Okay, let's just have them in a sorted order because we don't care about the ordering, right? Let's say this is my array and I ask you that how many subsequences are there? Okay, how many subsequences are there such that they contain at least one occurrence of 1 and 2 and no other elements should be there. So how do you like solve this? So this is again like you will divide them into two parts. Okay, so what you will do is, this is the first part. You will tell them, like you will ask that, hey, from you, how many ways there are such that I select at least one uh from this three occurrence of one. So here the answer is there are 2 raised to power 3 minus 1 ways, right? And here there are 4 occurrence of 2. So if I have to choose at least one occurrence of 2, so the answer will be into 2 raised to power 4 minus 1. That's it. And like if you still unclear, you can like try this. Okay, so see, if I ask you that how many subsequence will there be of this type, let's say this type. So you can just find that easily, right? See, what you will do is, let's say we have a frequency map. Okay, so this fr0 tells me frequency of 0, this fr1 tells me the frequency of 1. So sorry, I can just find this easily, right? For the thing, like if there are 3 occurrences, then the answer is 2 raised to power 3 minus 1. So if there are this much occurrence, the answer will be 2 raised to power fr of 0 minus 1 into, for this it is like 2 raised to power fr of 1 minus 1 to 2 raised to power fr of 2 minus 1 and multiplied by 2 raised to power fr of 3 minus 1. That's it. And this will be my answer of number of subsequence there are of this type. Like they contain at least 1 0, at least 1 1, and at least 1 2 and 3, and no other elements. Okay, that's it. Now this thing is easy. We can find it easily. Like you can also manually just iterate and find this, and this will be in O of n because O of n square can work. And there is also another method that is using something like prefix maximum. Because see, in this case, I want this thing, right? The continuous thing. And let's say if I am finding for some other subsequence, let's say subsequence is this, then I have to find this much part. Right, so for this, sorry, like for this, I have to find this thing, right? Okay, so like for 0 1 2, I have to find this thing. So now, can you find that if I have the some multiplication of this prefix, right? I can get my answer easily. Okay, there were two ways to optimize this. What was the first way? The one way is you find the answer for subsequence from the given order. See, the idea is that let's say when you are calculating 0, the answer is 2 raised to power fr of 0 minus 1. You have already calculated this. So after that, when you find the answer of 0 1, this is nothing but fr of fr of 0 minus 1 multiplied by 2 raised to power fr of 1 minus 1. So can you see that if I have already calculated the answer of this and now I want to find the answer for 0 1, I just have to multiply this, right? Then let's say when I go from 0 1 to 0 1 2, I just have to multiply this. So by this method, you will just get the answer in O of n, because there are n subsequence, and for each subsequence you can get the answer in O of 1. Okay, this was one method. And there is also another method, which is you just pre-calculate everything, right? So you just pre-calculate some multiplication of this range, because this is prefix sum type thing, right? So this is, so in this it will be prefix multiplication. That's it. So I can store something like prefix of 0. It will store 2 raised to power fr of 0 minus 1. Then let's say prefix of 1. This will store 0 into 1, right? Then let's say prefix of 4. So this will contain like something of 0 into some of 1, something of 2 into something of 3 into something of 4. Yes. Like by this something, I mean fr of 2 raised to power fr of 4 minus 1. This thing. So whenever I have to calculate this, I just ask my prefix sum that what is the prefix of 2, and I will get this thing. So yeah, this was the idea to optimize this. But yeah. Okay, I hope you understood this. Okay, high risk coding, you were able to solve 4. Okay, that's nice. Okay, that's nice, Sujal Singh Negi, for providing your ideas. I don't condition 1 only once, condition 2 0 1 2 till x. Okay, yes, this is correct. 2 raised to power frequency minus 1. Yeah, this is correct. So I hope you all understood this till this point. Like if you still have some doubts, you can share it in the live chat. If no, then like the logic is really easy. You don't have to, like, sorry, the code is really easy. the main thing was the logic, right? So there are going to be three conditions. Okay. And for each condition, we found that how the subsequence look like. Uh, okay. Pradeep is asking if I solved due to E. Uh, like the problem is the question of due to E was not in the due 4, but I just saw it and in that the like I just got some idea that one thing is clear, right? The condition is set in the tree, the number of the sum on the odd parity vertex should be equal to the sum on the even parity index, right? And then we just have to find. Okay, let's say that one tree is fixed, and okay, let's say tree is fixed and tree is something like this, odd. So this will be even, and this will be odd parity. So there are three odd, and there are two evens. So I just have to find in the array how many subsequence out there are, or like I just have to find grouping of three elements that I will put on the odd elements, sorry, odd vertex, such that that sum is equal to the on the e side it will be just sum by two. Right, sum by two will be the sum on the this three vertex and sum by two on the this two vertex. I just have to find this the number of grouping or number of subsequence they have sum is equal to this much, and this can be done by the knapsack DP, right? And then I just have to find how many valid trees are there, and I was not able to find that. Okay, one thing also I know is I have to use some type of prefer sequence, but I was not able to got this. Yes, odd parity should be the number. No, this cannot. Okay, yeah, this is correct. Okay, but okay, after this I will like try to see the solution and will explain this if I can understand. Okay, so let's see the code of this question. I mean, code is again really easy. Okay, there was something extra that was used. We have to use the modulo operator because the answer can be more than 118. So now the problem, okay, the problem is we have to find 2 raised to power something, right? 2 raised to power frequency. And how we can find this? So there are two methods, right? One is that you can find this in O of frequency. What you do is you just manually multiply everything. Right? Let's say you have to find 2 raised to power 5, you just do 2 into 2 into 2 into 2 into 2. Sorry, 2 into 2. Right? Manually you just go iterate and do multiplication. This will be O of frequency because there are 5 elements. I have to do 5 multiplication. And there is also logarithmic approach that which I used here, which is mul multiplication in log n. So see, if you don't know this, you can learn that like how to find the power in O of log n. You insert this and you will get some videos and also some blocks. Like the basic idea is instead of doing this, what we will do is we will break it in something like this uh 2 raised to 4 into 2 raised to 1. And see, I can find all this thing. Okay, sorry. Let's say like I can find 2 raised to 8 easily. What I will do is I will just multiply 2 raised to 4 two times and I will get this. I can find like I will multiply 2 raised to 8 into 2 raised to 8 and I will get 2 raised to 16. So yeah, I can easily get 2 raised to 32 and so on. And see, if I break it into parts like this, I can easily add them, right? And see, each of them can find in O of log n. So yeah, the total will be just frequency will be O of log of FR. So this is the approach. Yeah, I mean, okay, I'm not going to explain the code for this thing, but this thing is easy. See, let's go to the main code. So there are two things. First is I have to find the frequency of every element, right? So for that, I made the frequency array. So this is my frequency array. And in that, so first of all, this is all input. I make the frequency array. I count the frequency of everything. And after that, we have to do this prefix something, right? Is there is some problem? Okay. Now we have to make this prefix some type thing, right? So see prefix of I, or let's say prefix of I will give me what? It will give me 2 raised to prefix of 0 minus 1 multiplied by, keep multiplying till 2 raised to power fr of I minus 1, right? So what I do is, first of all, prefix of 0 will be this much only. So this is 2 raised to power fr of 0. Okay, this is 2 raised to power fr of 0 minus 1. And I do modulo. So yeah, you will see modulo everywhere just. And then I start from 1 till n. Okay, there was also another very important idea. Like I got the wrong answer because of this problem, which is that a of I can be till n, right? So I have to make the frequency array till n plus 1 of n plus 1. And yeah, also prefix of l plus 1 size. This is the mistake I did in the, like I did initially. Okay, so I make this prefix array. Now let's see. Okay, let's see how we will find this. So for this type of things, I will start from the 0th subsequence. I will keep going until n because the maximum is of size n. What will be the answer of this? It will be nothing but PR of 0. It will be nothing but PR of 1, right? So that's easy. Well, so that's what I do. So answer is equal to 0 initially. I go and like length from 0 till n, I just add PR of I. And what about this sequence of this type? So see, a sequence of this type can be break into two parts, right? Sorry. What I can say is that instead of this, I can say like continuous segment of 4, of length 4, which is this much, sorry, length 5. And I just add this thing manually, right? So like for this, the number of ways such that the 6 comes is nothing but 2 raised to power frequency of the 6 minus 1. So I will just multiply this. This thing is nothing but prefix of 4 multiplied by this. Also, there was some problem. The problem is this, like the only one, right? So I just assume that it is some subsequence starting from -1, but it doesn't matter. You can just like one way you can do is you can manually calculate for this and start from this. Also, I did something like same. You will see this. Okay, so then what I do is I start from -1. Okay, what is the maximum like length of the continuous segment I can have? See, because this is, let's say, n. Then this continuous segment will have length n minus 2, right? So that's what I do. I go till n minus 2 and I just find two ways, right? One is the continuous segment and one element. So this is the number of ways of continuous segment, which is prefix of I. So this condition is like, if it is -1, like I cannot find PR of -1. So I just assume that there is one way, else there is this much ways. And I multiply this with the answer for this one element, which will be this much. 2 raised to power frequency of ARR of I plus 2, or sorry, frequency of I plus 2 minus 1. So yeah, I multiply with this. So the total number of ways will be this much. And I add this into the answer. That's it. Yeah, for this question, I sorted the array and did knapsack DP. So if any element can taken, if it is ARR 5 is less than equal to current max plus 1. Okay. Yeah, that's also fine. But I guess time complexity will be O of n square, right? So yeah, uh, if the time complexity is O of n square, then you can just manually go for each subsequence and count the answer for that. But okay, your approach is also good. And knapsack DP. Let's go to the last question of our discussion. And it was kind of very interesting because there is no data structure or algorithm used in this one. You just have to find the observation. Okay, so a given array is said to be good if it can transform into 0, 0, 0 using the following number of operation. So what I can do is I can choose some index and I will subtract 1 from ARR5 and ARR5 plus 1. So it means that I can choose any pair of adjacent elements and I will decrement both of it. And I am given an array of A of n integers and I have to count the number of indices I such that there exists a valid integer x. If I change AI is equal to x, then A array is good. Okay, this. Okay. So this is our question F. Okay. So first of all, we analyze like what this operation means and what is the condition if we can reduce the element or not. So let's assume that my array is like this: 2, then we have 5, then we have 1. Let's say we have 5, and let's say we have 4. So if we have arrays like this, and the question is if I can reduce this element to 0 or like reduce this array to all zeros or not. How do I do this? So in this question, the main observation is that see, to reduce the first element, I always have to choose this pair, right? I can only choose this pair because there is no another way. See, if I have to reduce this one, there are two ways, and I don't know how many times I select this pair and how many times I select this. But for this one, the thing is clear that like this will be selected. Like I will select this pair 2 times and then this will be 0, right? So let's do this. So let's say we select this and do one operation 1 time. So both will get decremented. So it will be 1 and 4. Again, I have to select this and both will decremented and it will be like this. And now this is 0. So from that, we get another observation, which is to reduce this thing, like to reduce this to 0, I must choose this pair only because I cannot choose this pair. This is already 0. So if I choose, then it will be -1. I cannot do that. So now again, I have to for sure always select this. I will select this 3 times. So this will become 0 and this will become what it will become 5 minus 3, 2. Yeah. Then let's say to reduce this pair, I have to reduce this, like I have to select this 2 times, then only then this will be 0. So it will be 0 and this will stay 2. And this is 2. And there is no way such that I can select any pair that this will become 0. That's it. And you can say that by just iterating this way, you will always get the solution. I mean, you will always get the correct answer. See, I mean, so in this question, there is 2 remaining. So no, for this array, we cannot convert this into the array of all zeros. We cannot do this. Let's try another test case. Okay, let's say we have, okay, there is another method. Okay, let's say if my array was something like this, 5, 3, 10, okay, let's say this is 6, 4, and 3. Then I start from left to right, and I can say that, see, to reduce this first element to 0, I have to select this pair 5 times, right? I have to select this 5 times. But if I select this 5 times, then this will become 0 and this will become -2. So this is going into minus, and I cannot do that. So therefore, yeah, the condition is satisfied, right? I mean, see, the condition is that if ARR of I is, or you can say ARR of 0 is greater than ARR of 1, then I cannot do my operation. I mean, I cannot change this to the zeros. That's it. If no, then we will do the operation. Let's say this is like this. I do the operation and okay, let's say my array is like this, 4 and 5, right? I do my operation. So I do my operation 4 times. So this will become 0. This will become 1. Then I go to this point and I know that I have to select this pair exactly 1 time so that this one will become 0. So this will become 0 and this will become 5. Again, I come here and you can see that this is greater than this. So I cannot do the operation because I have to select this 5 times. And if I do that, then this will become -1. Okay, so this thing is clear, right? I have to go from left to right. I have to keep doing this operation. And if at any point AI is greater than AI plus 1, I break. Else I have to go to last and see if the last element is not 0 itself. Then again the answer is no, right? Because now I cannot select any pair. This must be 0, right, in the operation. Because I cannot do any operation now. So I cannot change this 2 to 0. So yeah, this was the way to solve this question. And also there is one more thing. I mean, if you iterate from left to right or right to left, the answer is going to be always same, which is correct answer. It doesn't matter, right? Because also you can say that because the array is symmetric. Okay, now let's say if we have some magical element at the left. Okay, what is the thing? Let's say my array is like this. 2, 6. Okay, this is my array. And let's say what I choose is that, okay, let's say I say you that you can choose the last element. You can choose the last element to be anything, right? Any value you can, like, you want. So how you will do this? Or can you say that in this type of array, can you always find the solution or not? Yeah, I mean, the answer is no, you cannot always find the solution because, see, if my array is something like this, then we can say that ARR of 1 is greater than ARR of 2. So I can never make this 10 is equal to 0. Even if I can have anything here, positive, okay. Yeah, this must be positive. Let me check. Okay, so the values are from 0 to 29. Okay, so it doesn't matter if it is positive or negative. But see, even if I can put any value here, I cannot change the condition of here, right? So, okay, so what is the condition? The condition is nothing. You will just keep doing the operation like you are doing, right? So let's say this we are here, we will do operation here 2 times. So this will become 0 and 2. We do operation here 2 times. So this becomes 0 and 0. We do operation here 0 times and there is 6 remaining. And yeah, if there is 6 remaining, so I will put the 6 here. So therefore we will do operation 6 times and now both will become 0. So can you say what is the condition? If there is a magical element here that you can change it anything according to you like. Okay. So see, if the array is fixed, the condition was clear, right? We do operation from left to right, and see at any point, if like I get my current element is greater than the next element, then for sure the answer is no. And let's say if I do the all the operation and in the last, if my last element is non-zero, then again my answer is no. Else my answer is yes. Okay, this was the condition. But see, if I have the magical element here, I mean, I can just use, like, I can make this element anything I want, then I don't care about this condition. Can you see this? I just have to see that I keep doing process and there is no element like which is like this. I can, so I mean, I want कि मैं ऐसे process करता जाऊंगा और ये वाला case कभी ना आए, right? This case never happens. Okay. And then only we will get it. So if, let's say if we can do the process and in the last, there is something here, then it's okay. In that answer is yes. So can I say कि for this type of thing where I can select the last element, the condition will be something like this. See, if this is then no, else the answer is yes always. Okay, I mean, still if you are unsure, just play with some test cases and you will understand this. Okay, let's say my array is like this. Uh, okay, the last element I can make it anything I want. So in this I start doing process. So I do process 2 times, so this will become 0 and this will become 1. For this pair, I will select this pair and do operation 9 times. So yeah, this will become 0 and this will become, sorry, 1 time. So this will become 9. In this, I will select this 9 times and then this will become 0 and this will become 1. Here I will select this and do the process 8 times. So this will become 8. And now because this is 8, so first this last element, which I can choose, I will choose it to be 8. And now this will become, I will do operation 8 times and this all becomes 0. Let's say some other case, which is 3, 1. Okay. So in this, we do operation on this 2 times. So this will be 0 and 1. We do operation here 5 times. So this will be 0 and 5. At this point, I cannot do operation, right? So the answer will be no. Like whatever element I put here 10. But can I do operation on this? No, I cannot do operation on this 5 times. So yeah, that's it. So this answer will be no. Okay. Can you do the same if this magical element was at the first position? Let's say this, and yeah, the elements are at this point. Let's say like something like this. The magical element is first position. Can you do the same? Yes, you can do the same because let's say now you iterate this from right to left, or you can just say that by symmetricity, if the left to right is correct, the right to left will also be correct. Or I just forget everything. What you can do is you can just reverse the array, right? You reverse the array, you count the answer by this method and put the element here. So I mean, this thing is also clear. So now, okay, what is the question? The question is like, I am given an array and I have to find the number of elements or the number of indices such that I choose that indice. I can change the value to anything I like. And after that, this is a valid index, or you can say that you can reduce this to 0 if that is valid or not. So how you can find this? So see, there is a important idea. Can I say, can I say that this thing is some type of the magical array, like because there are two elements fixed and the last element is like magical, right? I can use anything. And this suffix situation is also a case that we did, right? Like we considered this case where the first element is the magical one. We can solve this. Okay. So I can reduce this thing into two cases. One is this and one is suffix of this. So now what I have to find? I just have to find that. Okay. So for this prefix, what was the condition? Like the condition was nothing but can I do this operation? I mean, I will just can I do this operation? And I cannot get this. Okay, see, let's say some prefix valid. Okay, what I want to say is let's see. Let's say we will call some prefix as valid. If I do this operation and make the first n minus 1 elements as 0, right? So like what I'm just saying is that see, if this is my array and this is the magic index, so this is the like prefix of length 4, I will call it valid if I can change it something like this. There are all the zeros and there is one element here. For that, what I can do, I can just keep doing the operation. So this will be 0, this will be 1. Then I do the operation on this. So yeah, then this will be 0. And 4 minus 4, sorry, 4 minus 3 is, sorry, I will do operation one time. So because this is 1, right? So I will do operation one time. So this will become 0 and this will become 3. And I will do the operation here 3 times. So this will become 0 and this will become 5 minus 3, which is 2. So yes, we reduce it, right? So first n minus 1 elements are 0 and the last element is 2. And because of that, I will choose it like this. So, okay, this is the case. So I call this prefix as valid if I can do something like this. Okay, so can I make the prefix array, like, so let's say prefix array in which the prefix of I is like true. If we can change this prefix, I mean, from 0 to I, let's say if that prefix is valid, else it is 0, else it is false or 0, whatever. Can I do the same thing for the suffix? Yes, I can do same thing for the suffix. Yeah, this will be true if the suffix is valid, else false. And what do I mean by the valid? It is nothing but I can change this operation such that first and minus 1 element are 0 and the last can be non-zero or 0. I don't care about it. So that's it. Okay, how do you find this? So that thing was also like not that tough. See, let's say my array is like this. 2, 3, 1, 3, 1. Okay, and we want to make the prefix. Okay, so let's say this is my prefix array. So prefix of 0 like will be if I can make this prefix as valid or not. Prefix of 1 will be like I can make this prefix 2, 3 or not. The prefix of 2 will tell me if this 2, 3, 4 thing is valid or not. And yeah, so on. So prefix of 3, 4. 0, 1, 2, 3, 4, and 5. So yeah, till 5. So this thing, prefix of like this array is always a valid prefix, right? Like this thing will always be 1. For this thing, so what I will do, I will just say that do the operation. Okay, I will do the operation. And yes, so this will become 0 and this will become 1. Okay, so this thing is also valid. I mean, I can change it. Then what about the prefix of 4? Sorry, prefix of length 3. I mean, we know that till the prefix of 2, we did the operation and the last element is 1. Again, I can do the operation, right? I will just choose this pair and do the operation one time. So now this will become 0 and this will become 1. Okay, right? So this will become 1. Okay, did I did mistake? Oh, sorry. I'm really sorry. This is 4. This is 1. So I will do operation one time on this pair. So this thing will become 0 and this thing will become 3. And I can change this prefix into 0, 0, 3. So this is valid. What about the prefix of length 3? What about this prefix? So we can see that this value is 2 and this 3 is bigger than 2. So I cannot do the operation, right? So this thing will always be on 1, 0. So from this, the prefix of 3 is 0. I cannot make the prefix of 4 as all n minus 1 are all non-zero elements. I cannot do this. Right? Because see, like, even if I do the operation 2 times, this will remain 1, right? So yeah, from now so on, every prefix will be 0, right? So yeah, this will be 0, this will be 0. Okay, let's see the case for the suffix. Suffix of length 1, length 2, length 3, and so on. Okay, so like suffix of so I will make suffix in the reverse order, right? 5, 4, 3, 2, 1, and 0. So yes, this suffix is so like this is the suffix starting from the index 5. This suffix is always valid. What about this suffix? And see, we are now in the reverse order. What about this suffix? So for this, yes, I can take this pair one time. So this will become 0 and this will become 4. Okay, that's fine. So yeah, the suffix of 4 is also 1 because starting from index 4, this much suffix is a valid one. What about this? What about the suffix of length 3? I cannot make this 0 because this is 4. This is 1. I cannot select this 4 times. So this is invalid. So from now, every suffix, like every suffix will be invalid. Okay, and now, okay, let's see what thing we can get. Uh, okay, I forgot what was the initial array. Okay. Yeah, I remember this was 1, 1 and 0, 0, 0. So see, what I can do is that let's say I come at this point and I have to select this. And now I say that I can, like this is the magical point, right? So can I say that I have to check if this prefix is valid and this suffix is valid, right? So see, I is equal to 0, 1, 2, 3, and 4, and 5. So prefix of 2 should be valid. Yes, this is valid. And prefix of uh, what a prefix of 4 should be valid. Yes, this is valid. So if both are valid, then I can say that I can change this value to some value such that I can reduce it to make us 0. Okay, let's see example how we will do this. So how we can do this is what is happening. So what we can do is that see this is the array. I go from left to right till this point. I do the operation. So okay, we have not selected the value for this yet. Okay, so I select this two. This becomes 0 1. I select this two and do the operation one time. So this becomes 0. This becomes 3, and I start doing operation from this. So I do this and do the operation one time. So this will become 4. This will become 0. Now you can see I have to select magical element. Which element I will choose? I will choose 3 plus 4, which is 7. Now I will do 3 operation on this thing. So this becomes 0, comma 4. And then I will do this operation 4 times. So this will become 0. So that's it. So if I have some like prefix like this, prefix and suffix like this, I can make my arrays, and like for the ith element, the condition is that prefix of I minus 1 should be valid and suffix of I plus 1 should be valid. That's it. So let's read the code and you will understand this. So I take the input, I make the prefix and suffix element. How can I make this? So see, if at some point I get that current element is greater than the next one, then I cannot do the operation. So at that point, I will break. I will say that, okay, this prefix can never be uh, valid, right? So this can never be 1. Okay, and also this 0 means, okay, yeah, you know what prefix means, right? Prefix of I is equal to 1 means that the prefix from 0 to I, this array is valid. And if it is, sorry, if it is 0, it means it is invalid. So yeah, initially I just assume that everything is invalid. And see, if I can do the operation, I do the operation. So like by doing the operation, right? Let's say this is 3, this is 5. If I do the operation, this 5 will become 5 minus 3. So I do this thing here. AR is equal to this. And also make that prefix as 1. I can say that, yes, this is valid. Because if it was unvalid, I will break this. I do the same thing for prefix, suffix in the reverse order from n minus 2 to 0. I do the same thing. Yeah, just the thing is that this is the current element. Oh, sorry. This is the next element. So again, check the condition and break, else I will do ARR of I. This current element is this minus this, and I do this. Now how to check? So see, okay, let's say if I'm at 0th position, there is no prefix, right? And empty prefix is also valid prefix. So therefore is I is equal to 0, I just do it 1, else I check prefix of I minus 1. And same thing for suffix. If I'm at the last point and there is no suffix, I assume it to be 1, else it is SF of minus 1. And if both things are true, then and only then this like ith element can be changed such that it becomes 0. And yeah, after that I print the CNT. So yeah, I mean that's it in this question. If you have any doubt, yeah, you can share into the live chat. Also, any random question you can ask. If I mean, in the last question, Abhay, or I mean, can you please like further explain at what point like you are confused? Because see, in this, how I thought was that let's say if I this is my point, then what I know is that this prefix like I could something do. मतलब देखो द पॉइंट इज कि अगर ये वाला एलिमेंट चूज हुआ है तो मुझे यहाँ से ऑपरेशन करते हुए आना है आई विल स्टॉप एट दिस पॉइंट और सेम थिंग फॉर लेफ्ट राइट बिकॉज व्हाई आई डू द ऑपरेशन फ्रॉम लेफ्ट टू राइट क्योंकि देखो फॉर द A1 देर इज ओनली वन पेयर जिससे मैं ऑपरेशन कर पाऊँ राइट देन फॉर द A2 देर इज ओनली वन पेयर जिससे मैं ऑपरेशन कर पाऊँ राइट एंड एट सम पॉइंट देखो आई हैव नॉट सिलेक्टेड व्हाट विल बी द वैल्यू ऑफ दिस स्टिल पर देखो व्हाट एवर द वैल्यू ऑफ दिस A3 एंड A4 दैट्स ओके क्योंकि मैं उनके हिसाब से इस मिडल एलिमेंट की वैल्यू को डिसाइड कर दूंगा बट इफ आई स्टॉप फ्रॉम समवेयर like say If the values are like 5 and 3 and 8, I cannot do the operation on this thing because this is 5, this is 3. I want this to take 5 times, but this is 3. So I cannot choose this pair 5 times. And say like whatever the value I do, like whatever the value is here, this will not affect this one, right? I mean, see, if I do operation on this pair, this is going to reduce this element further down. So there can never be a case that I can do this operation. So that's it. And if that is the case, so what I will do is I will just do the operation. Let's say it was something like this. And I do the operation. So this will be 0 and 2. Then I again check if I can do the operation. Because see, if it stop at this point, I cannot do the operation, then whatever value of I choose here, it is not going to help. Okay, yeah, that's it. And let's say if at end point, I make this area something like this, that there are some zeros and the only this thing is non-zero. And also in the suffix, only this thing is non-zero. If that is the truth, so I can choose the middle element as the sum of these two and it will be right. That's it. Also, you can just see that, I mean, you can just do the operation like for this thing, you just have to see for this prefix and this prefix. And when you go to here, you have to see for this prefix and this suffix. So this was suffix. So yeah, this type of operation, and the idea is that you can find this easily. But it isn't it supposed to be suff of I plus 2 and prefix of I minus 2, cause all AI can change the previous and the next element. Okay, let me. But isn't it supposed to be suffix of I plus 2 and the prefix of I minus 2? Cause AI can change the previous and the next element. Okay, okay, that's a valid query. Okay, so see, but the idea was that uh, just give me a moment. See, the idea is why the prefix is valid. We are meaning by all the elements are zero and only the last element is some non-zero element. Let's call this x, right? So this is by the valid meaning of the prefix. Now let's say you ask that what about only the prefix of this I minus 2, which is the prefix of length 2, that is valid. So by that mean, I mean you are saying that this should be 0 and this can be non-zero element and this also can be non-zero because we just checked that this prefix should be valid. So now, okay, see, what if this x was greater than y? Let me give you example. Let me give you example. I mean, this can be true if you have the different meaning of saying what prefix means. But here, yeah, the meaning is that all elements are zero and the last element is non-zero. So see, let me give you example. Let's say this is 5, this is 10. This element is 4 and this element is, you can make it anything, okay? Now we want if this is valid, right? And yeah, you say to ask about only prefix of this. So 0, 1, 2, 3. So you ask about prefix of 1, if it is valid or not. And we will get this. Okay, we will get that, yeah, the prefix of 1 is equal to 1, which is true. Because you can change it to this and you can make this 5. So, okay. So I mean, the prefix of 1 is true, but still we cannot do the operation because see, this is greater than this. So that's the point. Sorry. Well, I mean, uh, if we are talking about the my condition, the way I declared the prefix, then it should be, it is false, right? Based on that segment. Okay, then it is not true because for this test case, right? I mean, let's just take this test case, 5, 10, 4 and Yeah, this can be 3 or something. This is the element we want to take, and this is my array. So you can see that the prefix of 1 is true in this case, right? But yeah, the answer is no. So that's a problem. Something might be remaining, so you need to check. Yes, that's correct. I mean, you have to check. Okay. So yeah, and also thank you, Abhay and Pradeep, for making this session interactive. Also, okay, so do you still have doubt, Abhay? Uh, okay, so like, just do the operation on this thing. Just make the prefix sum for this query, and you will get that it is not correct. Okay, it is a edge case for your. Read my previous statement. This one I mix on that statement. We have to check a of I is less than equal to a of I minus 1 or a of plus 1, right? No, I think this thing is 100% false, right? Because this thing is never true. So if you are talking anything about this, this is false because see in this case, let's say the elements are like this. Let's say 9, 10, and 3, and but let's say 2. So in this case, you can see that this 3 is not greater than the sum of 2. Or were you talking about less than? Okay, let me check. Yeah, a of I should be less than. Okay, so okay, then it will be okay. Then it is true. Sorry. Then it is true. But it is okay. It is a necessary condition. But is it a sufficient condition? I mean, by that, can you always say that your answer is true? I have to say this. This is my prefix and suffix array. Okay. Oh, nice. This is another method of seeing this. That's a nice approach. Okay. Let me like do some test case and see if this is correct. Yeah. 2, 3, 4, 3. Your index is equal to 1. You think it is not possible, but it is. 2, 3, 4, 3. That's it. 4, 3, I think that the Abbas logic is correct. Still, that can be like, I just have to think if that your condition is sufficient or not, like always. Okay, so I just have to like consider some more test cases and find mostly it is looking correct. And yeah, if you are making the this thing by yourself, then yes, this condition is correct. Okay, I mean this condition, whatever you said, yeah, this is correct. But still, there can be some case like okay, then Abhay, tell me how do you choose the value of the middle element, right? Because now there are two values, right? See, let's say you are choosing the answer of this value. So there is AI minus 1 and AI minus AI plus 1. And there is this AI minus 1. And yeah, the condition is that AI minus 1 should be less than or equal to AI minus 2 plus AI. And for the condition for this should be AI plus AI plus 2. So now you have to select the value for this AI such that both conditions are satisfied. Okay, so this is AI plus 2. Right. And okay, so how do you select the value, or is it always true? See, what you can do is you can find what is the maximum value according to such that this range is satisfied and this range is satisfied, or the minimum value such that this both are satisfied, and you see if there is one intersecting value. But again, like I think that I maintain the prefix. Yes, but yes, the problem is that okay, you just check if this prefix is correct and this suffix is satisfied, right? But now, according to this, to how do you select the value of AI? Because there are two ranges that you have to satisfy, right? This value should be according that this is satisfied and this is satisfied. Okay, it will be more better if you share your code, right? And can you like please share your code in the comment box and I will analyze that. But yeah, I have to say your approach was a nice one. I mean, the condition you made, that's good. So I have to end this discussion now and meet you in the next stream.